10, 11, and 12. Now we've got more than one log in our equation. What we want to do is get anything that has the word log in it on one side, anything without the word log on the other side, so that we can then combine our logarithm into a single expression. If we're adding, we multiply our values. Subtracting, we divide them. So, first of all, we're going to move this over here. I'm going to say log base 2 of x minus 1 plus log base 2 of x minus 7 equals the 4. Since I'm adding my logarithms, I can combine them into multiplying these together. So I'm going to rewrite it as log base 2 of x minus 1 times x minus 7 equals my 4. Eventually I'll FOIL that out. So now I can rewrite that in exponential form. So 2 to the 4th power is going to equal that, which I'm going to just go ahead and FOIL out. So 2 to the 4th power equals x squared minus 7x and minus 1x would be minus 8x, and negative 1 times negative 7 is plus 7. 2 to the 4th power, we obviously have to evaluate. 2 to the 4th power is 16. And since we have a quadratic expression, we want to set it equal to 0 so we can solve by factoring. So we're going to go ahead and minus the 16 to move it over to the other side. So 0 is equal to x squared minus 8x minus 9 now. We can never get away from factoring. So if we factor that out, how does that factor?
X minus 9 and x plus 1.
X minus 9 and x plus 1, which means my two possible answers for x would be 9 and negative 1. Now, when we go back and we check our answers, you can have a negative answer, but you cannot have a negative value to take a logarithm of it. So what we're going to do is we're going to plug it in here, and if whatever's in the parenthesis turns out to be a positive number, then that number's okay. Turns out to be negative, then we have to get rid of it. So 9 minus 1 is 8. I can do the log of 8. 9 minus 7 is 2. I can do the log of 2. However, when I put the negative 1 in there, negative 1 minus 1 is negative 2. I can't do the log of a negative number, so I have to get rid of that answer. And so x equals 9 is going to be my only answer on this one. So it's not necessarily that if this is negative, if it's after you substitute it in. If it's still negative, then we got to get rid of it. Number 11 then. I want to solve that for x. What should I do first?
Move your log over.
I'm going to move this log over here so I don't have a negative log there. So I'm going to have the log of 5 plus 2. That's going to be plus the log of 5 of x plus 6. And then I also then need to move my number to the right-hand side, so that's going to become a positive 1. So again, I'm adding my logarithms. I'm going to combine them into a single expression by multiplying the x plus 2 times the x plus 6. Oh, it's something sort of like that. So rewriting that in exponential form, I would have what was that? 5 to the first power, which is still just 5, equals x plus 2 times x plus 6, which would be x squared plus 8x plus 12, right?
Yep.
So we know 5 to the first is 5. We got to move that to the other side, so we're going to minus our 5. So 0 is going to equal x squared plus 8x. 12 minus 5 is 7. So now we got to factor that. That factors into x plus 7 and x plus 1, right? Means my possible answers are negative 7 and negative 1. So if I check that negative 7 out, negative 7 plus 2 is negative 5. Can't take the log of negative 5, so I got to get rid of that one. If I check the negative 1 out, negative 1 plus 2 is still positive 1, so that's okay. Negative 1 plus 6 is still positive 5, so that's okay. So my solution is that x equals negative 1. So number 12. We're going to rearrange that, put our logarithms on the same side. The leading one I like to stay positive, so I'm going to have log base 2 of x minus 7 minus the log base 2 of x plus 8 equals my 4. So our rule with logarithms is when we subtract logarithms, we have to divide those values. So when I combine that into one expression, I have log base 2 of x minus 7 over x plus 8 then. Equals 4. So rewriting that in exponential form, we would have 2 to the 4th equals my x minus 7 over my x plus 8. 2 to the 4th power is 16, right? So when we solve that one, since we have a fraction, we should do what next?
Subtract it.
Don't think so? How do we get rid of the fraction? Multiply, right? We're going to multiply by the x plus 8 so we can cancel the fraction out of there. So, using my distributive property, 16x plus, what's 16 times 8? $128 equals x minus 7 then, right? So solving that, we've got to minus our x and subtract our negative 128. This doesn't look like it's going to turn out very nice. 15x equals negative 135, and if I divide by 15 then, I get what?
Negative 9.
Negative 9? Negative 9. But I have x minus 7 up here, so since I have negative 9 minus 7, that's not going to work. We get a no solution answer on that one.